Hey everybody, in this video we are on part 3 of algebraic techniques for finding limits. This is lesson 3 on the limits unit. We already did example technique 1 is to factor and reduce. Technique 2 is to use long or synthetic division, and here we are multiplied by the conjugate. But I'm not going to lie to you, the particular example I have for us with multiplying by the conjugate, maybe I'll do 2. This particular example I find easier if we factor and reduce, so maybe I'll throw you a bonus example at the end of the video where it is going to be more practical to actually multiply by the conjugate, because you can't really take the same shortcut, right? Okay, so let's go. So here, multiplying by the conjugate. So a lot of people get in an uproar over here because they're like, what? But why would I do that? My denominator is rationalized. That's rationalizing my numerator. Well, I know, but buckle up, buttercup. So what's going on? If we try direct sub, we will get root 4 minus 2 over 4 minus 4, which is 2 minus 2 over 0, which is 0 over 0 in determinant form. Tells me I can cross something out from top to bottom. What is it that I'm going to cross out? Well, I'm glad you asked. That's this little devil down here, right? We got to get rid of that little devil because that is making the bottom equal 0, and that is what is not allowed, right? So when I multiply by the conjugate, I'm going to give myself the opportunity to cross out that x minus 4. At least that's the plan, right? Of course, we have implied invisible parentheses on both top and bottom. The conjugate is going to be radical x plus 2. Make sure you're careful. The radical symbol is only over the x. It is not over the 2. Okay, so don't get it, don't get it confused, twisted, backwards, or anything like that. The radical is only over the x, okay? We're going to put parentheses, but whatever we do on bottom, we do on top. Now, don't distribute the devil, okay? X minus 4, leave it alone. Leave it alone. Don't distribute. Top, we have, well, limit as x approaches 4. FOIL on top. First times first, root x, I get x. Outer, inner, anytime you multiply conjugates, they cancel out, right? Right. Minus 2 plus 2. Multiply, I get x minus 4. You're going to be so tempted to FOIL on bottom. I promise. It's going to be dangling in front of you like, I know you want to, but don't do it, because look, we wanted to cross out x minus 4, and look what you got on top. This will happen. If you get 0 over 0, I promise you a million times over, this will happen. This has to happen. Or if it doesn't, it's because you should not have gotten 0 over 0 to begin with, okay? So the bottom, there's the x minus 4, the little devil. And then the root x plus 2 is also in the denominator. So there I am. Now this guy, what did we say? He's got to go. You got to cross him out. So, adios. When we do such, what's left on top is a 1. It's not just root x plus 2 floating around by itself, okay? So we're really looking, the limit as x approaches 4 of 1 over root x plus 2. Now that that devil is gone, we can do direct sub. 1 over root 4 plus 2. 1 over 2 plus 2. 1 over 4. Winner, winner, chicken dinner. Okay? So that's how we do it in this way. Multiplying by a conjugate, we're rationalizing our numerator. It's lovely. So when do you multiply by a conjugate? You're usually going to have a radical on top. Look for it. Keep your eyes peeled. Be ready for that. Now, let's switch it up. Let's use a different color to make sure it really stands out as being different. And I'm going to rewrite the problem first. Limit as x approaches 4 of root x minus 2 x minus 4. Okay, that's the original problem. Now in green, how would I particularly do this problem? What I would do is limit, I'm just rewriting, x approaches 4 of the top, I'm going to leave alone, root x minus 2. The bottom, I'm going to factor it as if it were the difference of two squares. If that was x squared minus 4, we would have x plus 2, x minus 2. We basically take the square root of each component. But it is not, I repeat, it is not x squared, right? It is just x. So when I took the square root of x squared, I got x. Well, what's the square root of just x? Well, it's root x. Root x. Let's go over that in black to make sure we see it. That's root x, root x. So I have root x plus 2, I have root x minus 2. Now, what piece of this is really the devil in disguise? The piece that's the devil in disguise when I plug in 4 gives me 0 is this guy right here. If I plug in 4, it gives me 0. It's not really that other part. It's the root x minus 2. Can I cross that out? You bet your butt. So again, I'm left with the 1 on top. I get the exact same results. What are those results? Limit as x approaches 4 of 1 over root x plus 2. Right? I don't really need, those are a little squished, sorry. Then direct sub 1 over root 4 plus 2, blah, blah, same answer. Oh, I can't see, sorry. All right, so compare. Think about the two methods. Watch it again if you need to. I would argue there's a lot less writing in the green section than there is in the pink. I will give you the fact that I didn't write the last step and a half right there, but it's basically these same steps over here. This is a lot messier, a lot more room for error. So again, I factored x minus 4 as if it were the difference of two squares. The square root of 4 is 2, so plus 2 minus 2. That's how we factor difference of two squares. We use conjugates. And the square root of x is just root x. So we use root x. Voila. I hope you loved it. I hope it makes you happy. If you loved it, go ahead and give the video a thumbs up. Questions, comments, concerns, feedback, requests in the comment section. Check the description box for the full playlist or jump to one of the playlists on the screen now and find whatever it is you might need help with. I hope you are feeling smarter and I hope these videos are helping you. That's it for now. Adios.